So again, we are still discussing ionic bond formation, how ionic bond is being formed. So in this example, we are going to use MgO and then Al₂O₃. All these are examples of ionic compounds. They exhibit ionic bonds. Is that okay? So again, we are only going to use the symbol of the element, and then we draw a shell. Then we indicate its valence electron to make it very simplified. Now, the first one is Mg. We draw the shell. Mg has 2 valence electrons, that is magnesium. And then the second element is O. We have O, then we draw the shell. Oxygen has how many valence electrons? Oxygen has 6 valence electrons. So we indicate that as well. Is that okay? In order for Mg to be stable, unless it loses that 2 electrons. And then for O to also be stable, unless it gains an additional 2 electrons. Is that okay? So there's going to be a transfer of electron from Mg. So Mg is going to transfer the 2 electrons to O. Is that okay? So once Mg transfers the 2 electrons, it's going to change from the Mg neutral atom to Mg 2 plus without any electrons there. And then O, once it gains the 2 electrons, it will also change from the O neutral atom to the O2 minus, meaning that there's an addition of these electrons over there. Is that okay? The electrostatic force of attraction between the Mg2 plus and then the O2 minus is what we call the ionic bond or the electrovalent bond. And it brings them together to form the MgO. Now that is the ionic compound. Is that okay? I'm using this to make the diagram more easier for the illustration. We can choose to use all the shells. Is that okay? But I'm just using the last shell and its valence electron for easy demonstration. Is that okay? Again, let's consider Al₂O₃. In this one, we have 2 atoms of Al and then 3 atoms of what? O. So let's write Al. How many valence electrons do we have for aluminium? It has 3 electrons in its valence shell. So Al, there's 3 electrons there. So this one Al, we have 2 of them. And then the second Al, also with 3 electrons. Is that okay? Now we have 3 of the oxygen. So we have one O here with 1, 2, 3, 4, 5, 6. Another O here with 1, 2, 3, 4, 5, 6. And another O here with 1, 2, 3, 4, 5, 6. Each needs 2 electrons in order to attain stability. Is that okay? So for it to form Al₂O₃, which exhibits ionic bond, there should be a transfer of electron from the atom with the low IE, and that is the aluminium, to the atoms with the high EA, and that is the O. So Al is going to transfer 2 electrons here to this O. The remaining electron will be transferred onto the valence shell of this O. And then 1 more here will be transferred onto this O. And then the last one will also transfer its remaining 2 electrons onto this O. Is that okay? So what is going to happen? Once this transfers all 3 electrons, it is going to change to Al3 plus. Are we there? And then this will also transition into Al3 plus. Is that okay? Each O, after receiving the 2 electrons, it will change to O2 minus, meaning that there is an additional 2 electrons being gained. So we are going to get O2 minus over here, another O2 minus, and then again another O2 minus. So how many O2 minus we have? We have 1, 2, 3. So we have 2 of the Al₃ plus, and then we have 3 of the O2 minus. Is that okay? So the force of attraction that exists between these 2 Al₃ plus and then this 3 O2 minus forms what we call the ionic or the electrovalent bond. That is the formation of ionic bond. We have a lot of examples of ionic compounds which exhibit ionic bond. We can have LiF, we can have CaO, a lot of examples that you can also try as well. Thank you. If this is your first time watching our lesson, please don't forget to like and subscribe to our channel for more educative lessons.